Types of data and measurement scales. There are 4 measurement scales or types of data: nominal, ordinal, interval, and ratio. These are simple ways to categorize different types of variables or information. These 4 measurement scales are best understood with example. Let's start with the easiest one to understand. Nominal scale is a type of measurement scale. Values assigned to variables represent a descriptive category but have no inherent numerical value with respect to magnitude. This means that nominal scale is just a description or a name without any number or any value. Nominal scales are used for labeling variables without any quantitative value. Nominal scales could simply be called labels. Here are some examples below: male, female, religion, political affiliation. And another example: what is your gender? Your answer could be male or female. What is your hair color? Brown, black, blonde, gray, or other? Where do you live? North of the equator, south of the equator, neither in the International Space Station. So your answers here are nominals. It just give a description. It could be an address. Notice that all of these scales are mutually exclusive, no overlap, and none of them have any numerical significance. A good way to remember all of this is that nominal sounds a lot like name, and nominal scales are kind of like names or labels. Ordinal scale. With ordinal scales, the order of the values is what's important and significant, but the differences between each one is not really known. Ordinal scales are typically measures of non-numeric concepts like satisfaction, happiness, discomfort, etc. Ordinal is easy to remember because it sounds like order, and that's the key to remember what the ordinal scales. It is the order that matters, but that's all you really get from this. Take a look at the example. It's the first case. How do you feel today? So here are your possible answers with corresponding numbers. The second case: how satisfied are you with our service? And your answer with corresponding numbers. In each case, we know that a number 4, in this case we have happy. In the second case, somewhat satisfied, is better than a number 3 or number 2. So we have here the second case, we have neutral, somewhat, and satisfied. But we don't know and cannot quantify how much better it is. For example, is the difference between okay and unhappy the same as the difference between very happy and happy? We can't say. The best way to determine central tendency on a set of ordinal data is to use the mode or median. The mean cannot be defined from an ordinal set. Interval scales are numeric scales in which we know not only the order but also the exact differences between the values. The classic example of an interval scale is Celsius temperature because the difference between each value is the same. For example, the difference between 60 and 50 degrees is a measurable 10 degrees, as is the difference between 80 and 70 degrees. Time is another good example of an interval scale in which the increments are known, consistent, and measurable. Interval scales are nice because the realm of statistical analysis on these data sets opens up. For example, central tendency can be measured by mode, median, or mean. Standard deviation can also be calculated. Like the others, you can remember the key points of an interval scale pretty easily. Interval itself means a space in between, which is the important thing to remember. Interval scales not only tell us about our order, but also about the value between each item. The problem with interval scales is they don't have a true zero. For example, there is no such thing as no temperature. Without a true zero, it is impossible to compute ratios. With interval data, we can add and subtract, but cannot multiply or divide. Consider this: 10 degrees plus 10 degrees equals 20 degrees. No problem there. 20 degrees is not twice as hot as 10 degrees. However, because there is no such thing as no temperature when it comes to the Celsius scale. I hope that makes sense. Interval scales are great, but we cannot calculate ratios, which brings us to our last measurement scale. Another example of interval is your grade or score. If you get a 0, it does not mean that you do not have any learning out of the lesson. It's just that the given questions or quiz are the lessons that you have not studied. Again, if you got 0, it does not mean that you don't have any learning or have 0 learning. That's impossible. Ratio. Ratio scales are the ultimate nirvana when it comes to measurement scales because they tell us about the order. They tell us the exact value between units. And they also have an absolute zero, which allows for a wide range of both descriptive and inferential statistics to be applied. Good examples of ratio variables include height and weight. Ratio scales provide a wealth of possibilities when it comes to statistical analysis. These variables or informations can be meaningfully added, subtracted, multiplied, divided, or ratios. Central tendency can be measured by mode, median, or mean. Measures of dispersion such as standard deviation and coefficient of variation can also be calculated from ratio scales. So in this scale, it has a true zero. For example, if you are playing, if you don't get a score, then that's really mean that you don't have a score. When to use the mean, median, and mode. If we have the type of variable, what best measure of central tendency to be used? Nominal. What is the best measure of central tendency? Mode. Since nominal are just descriptions, name or label, you don't have any number, but the most appearing nominal or name or label, that will be considered. So we need to use mode. If we have an ordinal, the best measure of central tendency is median. If we have interval or ratio but not skewed, the best measure of central tendency is mean. If we have interval, ratio but skewed, we need to use median. Nominal variables are used to name or label a series of values. Ordinal scales provide good information about the order of choices, such as in a customer satisfaction survey. Interval scales give us the order of values plus the ability to quantify the difference between each one. Ratio scales give us the ultimate order, interval values, plus the ability to calculate ratios, since a true zero can be defined. Nominal refers to categorical data or dummy. We have two, real nominal and artificial nominal. An example of real nominal is gender. If you are really a female, then you are a female. If you are really a male, then you are a male. Artificial, for example, you're giving a passed or failed. Maybe teachers have different standard. Maybe the students that you have given failed is passing to the other teachers rather. Ordinal, ordered or ranked data. Ranking. Interval, arithmetic differences, no true zero values. Example, your grade. Ratio, proportion has meaning, has an absolute zero with an absolute zero. If we have here the following, the order of values is known to be ordinal, interval, or ratio. The frequency of distribution could be nominal, ordinal, interval, and ratio. The mode will be used to all types of data. The median will be used in ordinal, interval, and ratio. The mean will be used in interval and ratio only. Can quantify the difference between each value. We have the interval and ratio. Can add or subtract values. That is in interval and ratio. Can multiple and divide values. That is for ratio only. Has true zero. That is ratio. Exercises. Identify the type of data of each given. For gender, that is Real nominal. Test results, passed or failed. Artificial nominal. Performance rating of teachers or students. Ordinal. Scores in exam, that is interval. Scores in basketball. Ratio. Ranks in NAT, National Achievement Test. Ordinal. Educational background, elementary, secondary, or tertiary. Ordinal. Types of personality. Artificial nominal. Aptitude. Interval. Attitudes towards teaching profession or studying or something like that. Artificial nominal. I hope that you have learned the lesson.